All right, for today's deep dive, we're tackling what I kind of think of as the industrial Frankenstein problem.
Oh, I know this one.
Yeah, you've seen it. You have this, massive factory floor. The main office is all shiny, high-speed Ethernet.
Right.
But then way out in the field, maybe 10, 15 kilometers away, you've got these critical pumps or sensors still speaking a language from, like, the 1980s.
RS-232, RS-485.
Yeah.
The zombie protocols, they will not die.
Exactly.
No.
And you can't just plug an old serial cable into a cloud server.
Yeah.
So we pulled the specs on a piece of hardware that claims to be the universal translator for this whole mess.
We did. We're looking at the Thor broadcast F-2GET-RS-A.
Which is a mouthful.
It is. It's officially a full duplex fiber converter. But, just calling it a converter is, I think, underselling it.
How so?
Well, based on the documentation, this thing is more of a heavy lifter. It's designed to drag that legacy gear into the modern age without, forcing you to rewire the entire county.
Okay, so let's get into the hardware. Looking at it, it just seems like a contradiction in a box.
It really does. It's a true hybrid. On one side, you've got 2 Gigabit Ethernet ports.
Your standard RJ45s.
Yep. Handling up to 1,000 Mbps. That's all your modern data. But then literally right next to it, there's this green copper terminal block.
And that's for the old school stuff.
That's for the raw industrial serial connections. It physically bridges the internet age and the pre-internet age.
But here's the part I really want to dig into, the connection itself. The specs say it runs on a single strand of fiber. Now, don't you usually need two, one lane for traffic going out, one for traffic coming back in?
Typically, yes. And that's where a huge part of the cost savings comes from. I mean, if you're leasing dark fiber or digging trenches, every single strand counts.
Well, how does it do it?
It uses something called wavelength division multiplexing, WDM for short.
Okay, break that down for us. How do you stop all that data from just colliding on the same wire?
Think of it like using different colors of light. So the device sends data out using one specific wavelength of light, 1310 nanometers. Let's call that blue.
Got it. Blue light going out.
But it's listening for data coming back at a totally different wavelength, 1550 nanometers. We can call that red.
So because the light waves are different, they just pass right through each other on that same piece of glass. No crash.
They pass right through each other, which also explains why the datasheet says you have to buy them as a matched pair, a side A and a side B.
Right, because side A's blue has to talk to side B's red, and vice versa.
Exactly. They're mirror images of each other. You need the set to complete that circuit.
Okay, so we've solved the physics, but what about the reality of deploying these things? I mean, they're not sitting in a nice air-conditioned server room.
Yep.
They're in a utility box on the side of a highway. If I swap out an old sensor for one that's slightly newer, do I have to send a tech out with a laptop to recode the switch?
No, and that's the whole intelligence aspect. The docs highlight something called zero-delay automatic forwarding.
Which means it just figures it out.
It just listens and adjusts. It has automatic baud rate detection. So whether your machine is chugging along at, 300 bits per second or sprinting at 115 kilobits, the Thor unit, it just detects the speed and adapts.
Instantly.
Instantly. It's transparent up to 520 kilobps. You don't reboot, you don't reconfigure, nothing.
That's huge for maintenance. But what about survivability? If this thing is in a cabinet in a solar farm in the middle of the desert, can it take the heat?
It seems like it's built for exactly that. The operating range is -40 Celsius all the way up to +70 Celsius.
So frozen tundra to the inside of a baking car dashboard.
Pretty much. And it's not just the temperature. The specs also list 1,500 watts of surge protection and 15 kilovolts of ESD protection.
ESD, that's electrostatic discharge.
Right, so a lightning strike nearby or just static buildup from really dry air. In any industrial setting, electrical noise is it's everywhere. This box acts like a firewall for that voltage.
Protecting the expensive gear on either side.
Exactly. And the range we mentioned out in the field.
Yeah, how far are we talking?
The standard model is 20 kilometers. But if you look at the options, you can actually spec these out to drive a signal up to 120 kilometers.
Wow. That's a serious distance for a protocol that used to struggle to get across a large room.
That's the power of converting to light.
So let's pull this all together. For the engineers and managers listening, what's the key takeaway here? Why does this little box matter?
I think it's about asset life extension. You have these reliable, expensive machines that still work perfectly fine. You don't have to rip and replace them just because the connectivity standard changed.
You just give them a bitter translator.
A hot pluggable one, yeah.
Yeah.
It lets you run modern monitoring on, say, a 30-year-old pump over a single hair-thin piece of glass, and you don't have to worry about the weather.
It really makes you think about all that hidden infrastructure. You know, we're all focused on 5G and AI, but the world's water systems and power grids are often running on these quiet, rugged little boxes, translating 1990s dialects into 2020's speed.
And doing it invisibly, which is really the mark of great infrastructure, isn't it?
A great reminder that sometimes the smartest upgrade isn't the newest machine, but just the smartest connection. Thanks for this deep dive.